Hello, everyone. This is Miss Gibbs. I wanted to come with a video just describing normal probability distributions or continuous probability distributions that we're covering in Chapter 5 of this Math 152 class, coming out of the Elementary Statistics Picturing the World by Larson Farber book that we're using in this course. And I get a lot of questions about the area, the probability, the percent, X values, Z scores. What am I using? How am I using it? So I'm going to do a general breakdown of how to distinguish what you're doing and what you're finding. Then we're going to do one problem using multiple ways of technology to complete your problem and the table, of course. All right, so Chapter 5, Normal Probability Distribution. So we're talking about normal distributions and standard normal distributions. And our data, remember, is data that's collected, data values that have numbers in between whole numbers. So we're talking about 1.5, 1.6, 1.3, 1.25. So we have numbers that we can actually collect, or data values we can collect, and it has whole numbers and decimals, as opposed to the binomial distributions. Binomial distributions only have whole numbers. X equals 1, X equals 2, X equals 3, X equals 0. Okay, so let's go over some little things to remember. So this is our graph, just in general, that normal curve that we use. Standard normal distribution means that we are actually using our curve, but we have a z as our axis. And we always have the z equals 0 in the middle, which is our standard deviation. Remember, z is an exact standard deviation. We don't have just 1, 2, 3 standard deviations. These are exact standard deviations. 0.5, negative 1.5, negative 1.75. So with standard normal, standard means it's a standard that we're looking at as our axis. And just as a reminder, we are looking for area, probability, or percent. So they can give you this problem any three of these ways, and you're still going to do the problem the same way. Whether you use the table, whether you use your calculator, whether you use Excel. Area, probability, percent, we're going to calculate it the same way. Now, how do you actually calculate it? It depends on what side that you are working with. So left means if you're working with the calculator, you're going to use normal CDF, negative 10,000, and then your value, mean standard deviation. If you are using the table, you're going to use the table as is. And your shading, I like to shade, it should look like this, whether we have z-scores as our axis or x values as our axis. You're still going to set up the same way. Negative 10,000, positive 10,000. That just helps us to know what to put in the calculator. For right of z or right of x, our shading should look like this. In the calculator, you can do z first and then 10,000 because we have a starting point, and then we're going to 10,000 or some large number. It doesn't matter what it is. So whether it's a z or x, that goes first, and then the 10,000 goes next, and then your mean standard deviation. If you're using a table, we have to find our area and take the complement of it. So remember, our table is only reading left. The table is only reading left. So if your shadings do not match, you're going to have to take the opposite. So this is normal, not normal, but this is what the table is using. You're going to have to take the opposite because it's shaded on the opposite side. Even on this side of the table, the shadings on the opposite side. So it's always starting left on the table. So if you're using a table, 1 minus your area to give you your answer. When you're looking at in between means you're going to have to find both areas of your z-scores and subtract area minus area. Area has to be positive because we're dealing with probability. Area probability percent has to be positive. So take the larger number minus the smaller number, whether it be the area or probability, and just subtract them if you're using the table. Normal CDF for the calculator, it'll be your lowest Z and your highest Z. Notice no 10,000 because it's not shaded. Or your lowest X, highest X, and then mean standard deviation. So 5.2, notice the word standard is gone. That's because we're leaving everything in terms of X. So when we collect data in statistics, we collect a whole bunch of X's. We convert them to Z's if you want to use a table. If you want to use your calculator, you can leave it in X form. So in your notes, 5.2, you should see how this was how the data was collected originally. This was converted to Z. So this is an X. Then we converted it to Z. So you don't have to convert to Z unless you really want to. So you're going to work the problems out the same. Same way in 5.1 with a little change. Now we have a mean and standard deviation. So we're going to calculate with a mean and standard deviation. So this, again, this is a rough run through. I don't know your numbers exactly because I do update my notes from time to time. But notice in 5.2, we're using actual means and standard deviations. So that means we're in terms of X now. So calculator, I did my graph, I shaded. So I don't have a 10,000, so I didn't put a 10,000 in my calculator. For more than 35, that's going to the right. So that means I should have 35 and then 10,000, and then my mean and standard deviation. If you're using the standard normal table, which means you like to use your Z, you're going to have to convert each of your X's, whatever X you have in your problem. Convert your X to Z-scores, and then work them out like we did in 5.1 or in the first section. So 20 converted to negative 1.75, that was that area. 50 converted to 0.75, that's that area, and we subtracted to get those two in the middle. So same concept as 5.1, but now we're dealing with changing your X values given to Z values and then working it out. I'm skipping to sample distribution because I want to cover the other part last. So sample distributions, we're still trying to find area, probability, or percent, but now we have an actual sample size. So when you have a sample size, we have to check it and then use it. Check it and then use it. So the mean of our population is the same mean of our sample distribution of sample means. Our standard error or standard deviation must be converted. So population standard deviation divided by square root of n give us a standard deviation of the sample means. So this is what you're putting in for your mean and standard deviation in your calculator. Or if you're calculating it by hand, you're going to calculate that standard deviation with that divided by square root of n component. So you check your for central limit theorem, you check to make sure you have enough sample, 30, or whether the population is normally distributed. Then you work your problem out. So it's a little different. So if you're using the calculator, you still keep everything in terms of X. If it's less, then it's going to be still left. If it's more, then it's going to be greater. So this was less than 12,250. So I still use my negative 10,000, 12,250. My mean, that's my population mean, but this is my mean of my sampling distribution. And then that's my standard deviation. I checked my sample size. It was not big enough, but it said that my population is normally distributed. So that makes me, be able to do the problem. So that's when I put my square root of 9 in at the very end with that standard deviation. Standard deviation that was given divided by square root of n. If you are converting your x to z because you like that table, then you're going to have to do your x value minus your mean divided by standard deviation. But remember, we have a standard error now because we're in sampling distribution. So if you're given a random sample, you have to check it, and then it's the last thing that you use. So that's your z. When you go to your table, that's your answer. Now, normal approximations to binomial distributions, we're still finding the area, the probability. Normally not percent, so area probability. This is a binomial problem. They're going to give us a p, and we're going to convert our binomial problem to a normal CDF problem or a normal distribution problem. Okay, that involves correction. So you have to see that phrase, normal approximation to a binomial distribution. You have to see all that whole long phrase that we saw at the beginning of that section. And then you're going to work it out a little differently. So you have to check to make sure you have at least 5 successes, 5 failures, because we're not given a mean, and they're given a standard deviation. We are given a passing rate, and we're given an n. So just got to make sure we have at least 5 successes, 5 failures. Then we have to correct our binomial passing rate is given, so we can use it in our normal CDF. Remember, normal CDF or normal distributions, we can have those in betweens. So we're converting our in betweens. So make sure you look up continuity correction if you're not understanding how we went from 15 to 14.5 to 15.5. So these are our boundaries if using the calculator. Our mean is going to be our n times p. Our standard deviation is going to be the square root of n times p times q. If you're using the table, x minus mean over standard deviation, same thing. So that's our x value, mean, divided by the square root of n times p times q, which is our standard deviation. So for the table, we have to use the z1 and the z2. We have to find both z's, 14.5, 15.5. Find those areas and subtract. Now for the last part. In 5.3, we're given the answer. We're given an answer of an area, a probability, or a percent. So they give us a probability, or they give us an area, or they give us a percent. We got to work backwards. So what you're going to do with your table is you're going to find that area and work backwards to find that z-score. So 0.5 to 0.9998 is positive for my table people. 0 to 0.5 is negative. Is negative z-scores. So you can go this on this side. So find your area, go outwards, and then find your z-score. So if you're going to use inverse norm in the calculator, we go over this in class. Just make sure you know how to use the inverse norm. We're using this because they give us the area. The area, the probability, the percent is given to us. So we're working backwards to get our answer. So to find your x values, that was to find the z, inverse norm, and then using your table to find the actual x value. So a data point. You're going to either use this formula, which is also on your formula sheet. And it says transforming a z-score to an x value. That's because you use the table. So when you use the table, you're going to use that formula. If you use the calculator, inverse norm area, notice it's not 0, 1. That's because it is the mean standard deviation, but we actually have mean and standard deviation given to us in our problem. So it's going to spit out means and standard deviation. Key thing to remember about this is some of you have left, right, center calculators. Some of you don't, so you may have to manipulate your work according to what type of calculator you have. So if you're using a table, you have to know whether your area that's given, is it left, right, or center. So in this problem, top means right. So we had to take 1 minus this and find it on the table. If it's bottom or less, that means it's left. So we use it as is when it's bottom. When it's in between, I do have an example of that, I believe, in your notes. So just make sure you look at that. And then if you have a calculator, and then you'll find that z-score and you'll plug it into that formula. If you have a calculator, depending on your calculator, you may have to manipulate your area. I don't have a left, right, center calculator, so right, I have to do 1 minus, just like the table people do. Inverse norm, you leave it as it is and you tell it where to find the actual x value. So notice I set up my graph just like I normally would using the x values. Top 10%, I don't know where that is exactly, so I just kind of shade it over here to give me a relative area of where to shade. And then we find our answer and make sure it makes sense. And it does. So it's about 63, so it should have been somewhere over here. I didn't shade 10% of my graph, so that's the best I could do. And so that is the gist of chapter 5. Area, probability, and percent. You're going to use that table and that calculator, or you're going to use Excel. If they give you area, if they give you probability, or if they give you percent, and they're asking you to find a z-score or an x value, that's when you have to work backwards, going from inside that table and out, or you're going to use inverse norm in your calculator.